All right, and today we're going to go over how to graph logarithms. Now, I know we already did this, but I kind of got some feedback, and it definitely seems like you guys wanted some extra practice with this. So let's go ahead. We're going to go over how to graph logarithms. So when you first graph a log, what I want you to think about is the parent function, okay? So this is clearly a base 3. So the parent function of this graph would be log base 3 of x, all right? And we talked about how parent functions have kind of set points. We know that the asymptote is always here at x equals 0. It always happens at 0. Then these parent functions also have a point at 1, 0. And the reason for that is anything to the first power gives you 0. So this is always a point on a parent function graph. Then the next point occurs at the base, which in this case is 3, 1. So it's always base, 1. Here our base is 3, so it would happen at 3, 1. Oops. So if we were to have if this graph was not transformed at all, it would look something like this. It would go through those 2 points, and that would be our function. However, this graph is transformed. We have a +5 and we have a +2. So if you recall, when we have a +5 on the inside, that has to go with horizontal, right? Our horizontal shift. So that tells us that we're going to go 5 left. And how do we know that? Well, this always goes in the opposite direction that you would think, right? So instead of going +5, we're going to go -5, so we're going to go 5 to the left, because the left is in the minus direction. Then the +2, the number on the outside tells us up and down. So that tells us we're going to go 2 up, and this actually does what you think it would. It doesn't do opposite. If it's +2, we're going to go up 2. So now what we're going to do is in red, I'm going to go ahead and graph this function. So our original point was at 1, 0. So we have to move this point 5 left and 2 up. So we're going to go 1, 2, 3, 4, 5, 1, 2. So that is our new 1, 0 point. Then we're going to move our 3, 1 point. So we're going to go 5 left, 1, 2, 3, 4, 5, and 2 up, 1, 2. And that is our new 3, 1. Then we have to look at our asymptote. So the asymptote really can't get shifted up and down. It just gets shifted left and right. And so that means we're going to move it 5 left. 1, 2, 3, 4, 5. This is our new asymptote. Could you shift it 2 up? Yes, but the asymptote goes on forever up and down. So if you wanted to go 2 up, it's still going to be in the same location. All right, it's really the horizontal tells you where your asymptote is. So then at this point, we're good. We can go ahead. And this red line is our function here. All right. So let's go ahead. I'm going to do number 3. I wanted to change it up because number 3 has a different base. Okay. So again, we're going to plot our 3 important things. We're going to plot our asymptote of our parent function, which we know is going to be at x equals 0. And we know that every logarithmic function before it gets shifted goes through 1, 0. Then our base is 4. And if you recall, it's always your base, 1. So here our base is 4. So we're going to do 4, 1. So this here, what I just drew, is my parent function. But now let's apply our transformations to it. So this 1 tells us to go 1 to the right. How do I know it's to the right? Well, it's -1, all right? And the numbers attached to the x do the opposite. So instead of going -1, we're going to go +1. So we're going to go 1 in the positive direction. Then for my y, we're going to go 2 down, right? This value always does what you think it would. It tells you to shift 2 down. Oh, and I accidentally forgot to write 4, 1. All right. So now let's go ahead and apply these transformations to our points. So first, we're going to go 1 to the right. So I'm going to go 1 right, and then 2 down. 1, 2. So that is my new point. Next one, I'm going to go 1 to the right, 2 down. 1, 2. Again, my second new point. Then I need to shift my asymptote. Tells me I'm going to go 1 to the right. So I'm just going to go up 1, and this is where my new asymptote is going to go. All right. So this red graph, here I'll erase all my blue, which is my parent function. My red graph is my new function here. All right. That is this guy graphed. All right. I do want to show you guys how to graph this on Desmos. I saw a couple of you guys kind of struggling when we were graphing this the first time. So if I wanted to check my answer, let's see, I was like, I want to make sure I did this right. I want some good points. You can always go to Desmos. All right. So you go to Desmos and you're going to type in y equals. Then we have to write in log. So you're going to touch this ABC and you can type in log. Now, a lot of you guys struggled with getting this, the base. So if you look right next to, if you look in, I wish I had a pointer here, but if you look on the left-hand side of this keyboard with the letters still up, right next to the 1, 2, 3s, we have this A with a B base. You actually touch that, and that puts it in the base. So when you do that, you can put a 4. All right. And then to get out of the base, you're just gonna like click on your function to pull it out of the base again. Parentheses, x minus 1, close parentheses, minus 2. All right, so that gives you your function here. And let's say you wanted to check some of the points that you had. If you look right here at the function that you typed, right above it to like the left-hand side, you have this little settings gear. You're going to click on that, and you can click on a chart. All right, so it tells you that 2, -2 is a point, which that is a point that we put on our graph. You could also just check different points. Oh, whoops. 3, 4, 5, 6. All right. So you can go ahead and check some of the points on your graph and see if that worked. So let's see. Can I get it to pull up? No, it's not working. That's okay. So you can see here, you could kind of cross-reference. I did have 2, -2 on my graph. I had 5, -1 on my graph. If we go look, did we have that on this one? Yep, right? We had a 2, -2 and a 5, -1. So you can use Desmos to help check your answers.